We're looking at an insulation tester here, commonly called a Megger. And the purpose of this tester is to check for the resistance of the windings of a device like an electric motor using a fairly high voltage. You'll see on these three scales we have a 250 volt, 500 volt, and 1000 volt setting. And we need these high voltages to be able to detect certain types of faults. I'm going to illustrate this using this Baldor 7.5 horsepower motor. This is a failed motor who was pulled out of service because it has a ground fault in one of the windings. I want to demonstrate how we can prove that with our Megger, our insulation tester. First, I'm going to take the ground clip and move that to an area on the motor itself where I get a good solid ground. Next, I'm going to take a look at my three-phase windings right here coming out of the junction box on the motor. I've got a blue, an orange, and a white, and I'm going to measure continuity with my insulation tester between these phases and ground. So the way I'm going to do that, I have to be safety conscious here because this does put out a fairly high voltage when it does the test. I'm going to make my connection between my test probe and the bare end of the wire as such, and then when I make that connection, holding that with one hand, I'm going to reach over with my other hand and push the orange button on the Megger tester to actually energize it. So here's my connection being made. There's the button, and notice how the needle swings over all the way to the right. Because this is on one of the orange scales, we read it on the top of the scale, and swinging all the way to the right means 0 ohms. That's a fault. We should not have 0 ohms. It should be a very, very large resistance between any phase winding and ground. I'll do it again for this other phase winding right here. I'll make contact with my probe, and I'll touch the button. We see that also reads 0. And of course, doing it over here, on this winding, we read the same thing. Now I say of course, because it doesn't matter which winding in here has actually failed to ground. If I read to another one of these lines, I'm just going to read through one of the good windings to the failed one. So all I need is one ground fault anywhere in this motor. I'm going to read faulted to ground at any one of these lines. Now just to prove to you that the high voltage actually matters, it makes a difference to our measurement, I'm going to switch this to the low voltage range. In the green mode, this right here is acting as a typical ohm meter. And as a typical ohm meter, it uses a very low voltage to test for resistance. Just to show you how this works, I can take this, touch to my ground clip, and you see right here, it stays on the left-hand side of the scale because on the green scale, right is infinite and left is 0. So a dead short would be the very left-hand side of the scale, and open would be the right-hand side of the scale on this low voltage setting. Keeping that in mind, I'm going to make my connection here again with the phase winding. As such, and push the test button. Notice it swings to the right. Remember, in this mode, that means open. That would indicate a good winding. Just to prove to you, I'm going to hold this button down and remove the probe. It stays over to the right. It's still reading open. In other words, the ground fault is not being detected on a low voltage mode. The ground fault is only being detected on a high voltage mode. So I come over here, make my connection. Just to prove again how this works, I've got my connection made. I'll push the button. It swings to the right, which means 0 ohms, or low resistance, in the high voltage mode. If I open this up, watch what happens. It swings to the left, meaning open. So clearly, I can see there's a fault in this motor using a high voltage setting that I don't see with a low voltage setting. And that is the unique value of a Megger style insulation tester.